Enthalpy changes in chlorination are fairly straightforward to calculate. We're going to be using bond dissociation energies here. Now when we go through and do these calculations, we need to remember that in initiation, it's a rare step, right? So it's not necessary for this step to occur for each molecule of product to form. So does it matter in the end? It does, but it's kind of like saying that the mass of the Titanic changes when you throw off a chair. It changes, but it's not by much. So we're not going to include it. What we're going to look at is propagation step. So let's take a look and let's go through and calculate what our delta H for this reaction is. So our BDE for CH3H is 104. So that's going to be 104, right? kcals per mole. Formed. So what was formed? HCl. That was formed, right? So that's broken. That's formed. This is 103. So the delta H here is equal to 104 broken minus formed 103. That's kcals per mole. You could do it in kilojoules. Some tables will list that. So that's going to give you a delta H here equal to plus 1 kcals per mole. So that first step is slightly endothermic, right? All right, we can do the same treatment down here below. So broken, here's chlorine. Chlorine is 58. So 58 kcals per mole. Minus formed, that's formed. So here, 85, 85. So delta H for this is equal to broken, 58 minus formed, 85. Again, kcals per mole. And when you go through and you calculate this, negative 27 kcals per mole. So this is exothermic step, right? So then if we wanted to calculate the delta H net for this, it would be equal to the delta H for propagation 1 plus the delta H for propagation number 2. Right, so we can see up above that's positive 1, right, minus 27 essentially, right? So kcals per mole. So that gives us a net delta H here of 26, negative 26 kcals per mole. So that number, I want to point out to you this number here and that number right here. Right, and then termination we don't include either because those are rare also, so they don't play a big role in the overall delta H. Now when we look at the energy diagram, guys, check it out. Here's where we're starting. So here's our CH4 and our chlorine radical. So this activation energy is something that we'd have to look up. It's not something we could figure out from our BDEs. But we come over here and we want to be plus 1. So this right here needs to be positive 1. So that difference right there is our plus 1, right? That's your propagation step. Delta H is a plus 1. And then propagation step number 2, we're starting here. Again, activation energy, we have to find that somewhere. But we come down here and we need to be lower by 27 kcals per mole. But we started off at a place that was higher by 1. And that's why we need to overall have our delta H overall is from here to here, right? That's the negative 26 kcals per mole. Now the other thing to point out here too is that as we go here from our reactants over this direction, this hill is our largest, so that is the rate determining step, right? So sometimes we label that as the RDS. Okay, and then coming here, that's a little bit lower of a hill, and then we can easily come down here to form our products, and that's an exothermic step there.